Hello everyone, to our final day of our dairy technology lecture series. Today we're going to have two speakers, but first a little bit about the Engineering for Food and Drink Special Interest Group. I am Daniel Heft, I am the chair of that group, and our main purpose is to promote the profession of food engineering, to have events such as these ones today where we get people together, pick a specific technical topic and present on it. We're going to record our lectures and they're going to be post-edited and then uploaded onto YouTube. I am also today accompanied by our CEO, Charlie Nicklin. And today's first speaker will be Professor Ulrich Müller. In fact, he is a professor, well, he was my old professor in food process engineering at the Technical University of Applied Sciences, OWL. He is also involved in the Institute of Food Technology for the Federal State of North Rhine-Westphalia and many other groups. And today's topic will be about counterstream injection technology. He will present a couple of case studies on things he did in the past and then how that may be of value for the dairy industry. Uli himself studied chemical engineering at Technical University in Dortmund. And he did his dissertation in the field of bioprocess engineering in 1991. He used to work for Haag in Bremen. It's a very well-known coffee place in Germany, the German Institute for Food Technology in Quakenbrück. And he is now responsible for the Department of Process Engineering since 1996 in Lemgo University. And his main research interests are in short processes that lead also to lower energy requirements or energy consumption and soft treatment or gentle treatment technologies. And one of these projects he's going to present today. Other things include his database for DNZ values, may be very interesting for all our listeners in the microbiology field. The database is openly and freely accessible for everyone. It's a lifetime project. And I know it's very much a hard project of Uli's. Then also short distillation projects, fast freeze drying and dynamic freeze drying technology is very interesting also, again, for maybe people in our agricultural end. And in general, Industry 4.0 technologies with particular emphasis on dough processing or baked good processing. Over to you, Uli.
Yeah, hello. I'm Uli Müller from this small German University of Applied Sciences. It's like a polytechnic, yes. And next slide. I have problems with steering here. Okay. That's another first slide. Okay. Yeah, I'm happy to say some words today about one of the technologies I made a little bit research the last 25 years. That's that time I'm here, professor for process engineering. We have 3 campus at our little Technische Hochschule OWL. One is Lemgo at the main campus. Here also we have the administration. Yeah, what means OWL? That means in German Ostwestfalen-Lippe, East Westphalia Lippe. That's the eastern part of North Rhine-Westphalia. Lemgo here, where we are sitting, is a very old town. Maybe you know the so-called Hanse Society. It was in the late Middlevian and society of merchandisers, very well known, spread over northern part of Europe as well as London. Yes, and we have a total 6,400 students, about 3,500 here in Lemgo. And here we have this faculty I'm belonging to. We are a university which is very research of field. So we like to make research, and We are one of the 10 best research applied universities. So we are not a full university. We are not allowed to make a PhD, but with the bachelor master concept we have here in Germany since 15 years, we are allowed to make a master, what is a progress for us. And yes, and I'm also responsible for this master course, was and will be in future. Okay, in our faculty we have a lot of courses, bachelor courses. First of all, food technology. This divided up in 3 specifications of beverage technology, bakery and confectionery technology, and meat technology, not dairy technology. Dairy will be taught in a similar University of Applied Sciences in Hanover, what is 100 kilometers in the east, northeast a little bit. It's the capital of Lower Saxony. I know that you know Hanover. It's one of the famous German towns. There we have a Hochschule Hannover where dairy is taught and or taught. I don't know whether it's right at the moment. So we do it not because it's so far, it's so narrow in the neighborship. So it's too yeah, it's here in the neighborhood. It's not so good. But we have another courses about cosmetic and detergent technology. Creams and emulsions are very important in food, but cosmetical is also emulsion, so it's very near to make this course here. And we are the only one university in Germany who makes so-called cosmetic and detergent technologies. Besides, we have pharmaceutical technology and biotechnology, but we have only one master course where we reset the gaps we have. We have gaps, of course, in basic science. We have gaps in some engineers directions, so like process control and modern process control, environmental technology. So we have no time for this in the bachelor course, so we do it in the master one, and we have some other nice subjects there in the master course. However, I'm teaching in this department what the name is life science technology, one of 10 departments we have in our little university. I'm teaching process engineering. So I am a serviceman for all my colleagues who are involved in the specification I have mentioned. In the master course, I'm also very engaged. For example, I teach the students heat and mass transfer or rheology, like such subjects. So Daniel mentioned that my my research hobby is to optimize unit operation and process technology to make them shorter, what gives a better quality, to reduce and the energy consumption, what means lower friction, for example, and at the end, this gives a higher yield and less wastage. That is my motivation. And specifically, I developed the so-called mechanical steam decontamination instead of the classic heat thermal decontamination for plant materials like herbs, spice, and drugs, which needs 20 minutes. We have a process of 10 to 20 seconds only, yeah, because we separate the germs, the microorganisms from the plant surface by a so-called flash effect. And it's a very, very mighty tool. and due to the short time, we get a better quality. The active substance, are still in, and whatever you want, the color is good, and something like this. Besides, Daniel mentioned the dynamical freeze drying. Normal is this statical freeze drying process. We can short the process time dramatically, more than halving in the last results. And the same to shortening up the process time is the example of vapor distillation. What is the process to get essential oils? Normally 3 hours, and we are successful to get the essential oils from such a plants like oregano, thymian, lavendel, mint, and such so-called Lamiaceae. That's the Roman name, Latin name for all these plants. So in 3 minutes we get the essential oil, and we have the suspicion that the quality of this essential oil is better. So it has a better anti-bactericide effect. So and one addition example for a short process is that what I want to say today, the Counterstream injection. And let me come to this topic. So the agenda maybe is not so important to shorten up my lecture. But I gave 2 examples, no example from the dairy industry, but in the outlook, I'm convinced there we will find places also for this technology in the dairy sector. So I come to an introduction. So I'm convinced everybody of you know what are emulsions. That is, emulsions are used everywhere in the field of food, especially beverages, in the field of cosmetics, pharmaceutical, and so on. Yeah, as creams, for example. We have water in oil emulsions, but mainly oil in water emulsions. So the oil is the so-called dispersed phase, and the aqueous phase in the surrounding are the so-called continuous phase. The problem is if the oil phase is too big, that the particles are of too great size, so the emulsion are not stable, and so we have the task to get small droplets during the emulsion forming process. And what is very important, not only small, the particle size must be also uniform. However, normally this process of diminuting the emulsion size is the so-called homogenization process. This homogenization, or for this homogenization process, we have a lot of apparatus and principles, and yes, and this emulsion we want to produce has a lot of different viscosities, what is very important. And I will show you that this technology I want to present now is independent to the viscosity of the emulsion product later. So normally, if we want to produce a stable emulsion, we have a first step of a production of a pre-emulsion, and we have a first coarse droplets, and this coarse droplets must be diminuted later to smaller particles. An example is a cloudy lemonade like Fanta, like Mirinda, like the French lemonade Orangina, maybe you know it. So we produced this first a pre-emulsion, and later we produce the ready-to-drink lemonade. The apparatus we use there is a high-pressure homogenizer, what we all know from the dairy industry to homogenize the milk. In the cosmetic industry, and if we have more emulsion of higher viscosity, normally we use rotor-stator apparatuses. Yeah, there are a lot of machines available. Yeah, but I show you that our technology will also handle this kind of products. Yeah, and this new technology I want to present is not my invention. This is a development of the rubber industry, specialized polyurethane industry. A polyurethane is a so-called two components polymer, and the two components are insoluble each other. So we will later have a reaction, the polymeric reaction, but this reaction takes place at the surface between the two faces. So we must a very intensive homogenization process to be or to get a successful surface controlled reaction to make a network of this polyurethane. However, they learned there how to bring two phases what are principally insoluble together. And the question was, can we use this technology, which is generally known counterstream injection technology, especially here counterflow injection technology, and therefore this abbreviation of CFIT, can this technology used also in other fields to produce consumer products, for example, to make lemonades, to make cosmetical creams. This was the task, and I was involved in this projects since 2009. So let me discuss what processes and apparatus to produce stable emulsions are known. In this only one slide. Okay, I mentioned the rotor-stator machines, normally with high turbulence stirrer, so-called rear rim disperser, like Becomix. That's a German company. We have also colloid mills, which make a more laminar shear stress. So these are all rotor-stator machines, and I mentioned these are used mainly in the field of producing high viscosity emulsions, creams, cosmetical creams. There is also a development to make a rotor system, so you will have higher shear rates, what gives more small droplets dispersed phase with a so-called co-twister system. The German company Cymex delivers such machines. And for low viscous systems like milk, also to make a pre-emulsion for lemonades, I mentioned the high pressure homogenizers, as you know, as well. Ultrasonic emulsifying by membranes is, as I'm convinced, only research. I know also the people from M4E. That's M4E is the abbreviation of magnetic for emulsions. It's a Belgium startup. Yeah, I saw how it's work, but I have not understand it totally up to now. Extruder technologies are a little bit discussed to play a role to make a small lipophilic phase, but also for high viscous systems in starch, for example. But what is now what I wrote under the red background, that's all the Counterstream technology. So Counterstream technology is a sampling word for a lot of neighbored technologies. You know all the Microfluidizer. Maybe you know the microjet reactor that is not so well known. Ecato nanomix maybe. Yeah, this is all Counterstream injection. But I separate from these technologies what we do with the machine from the polyurethane industry, the counterflow injection technology. Yeah, this works without making a premix. In any case, we can take the lipophilic phase and we can take the aqueous phase and then directly make a stable emulsion. So let me tell the difference. First of all, our way is red, maybe that's the lipophilic phase, the oily phase, and this blue may be the aqueous phase. So they collide in a mixing chamber directly. And the other Counterstream procedures, they make a pre-emulsion that shall be shown here in this part of the slide. So we have here this oily droplets, dispersed droplets. So we have a pre-emulsion and we have a pre-emulsion here from the other side, and this pre-emulsions collides in a mixing chamber. And I'm convinced you have to divide these technologies. So Microfluidizer belongs to the concept B, where you have a pre-emulsion, divides the streams in two streams, substreams, and then here we have the collision, the so-called stagnation point. Oh, excuse me. Yeah, and then we have the end product, which may be stable. The pressure we need are 1,500 bars. So we have a pressure pump here, and let's make very small particles. Yeah, but a pre-emulsion is necessary. This technology of the well-known Microfluidizer is something else than the microreactor. This is very similar to our system, CFIT, but we have additionally gas as transport medium. But you see here we have a liquid raw material phase coming from here and the other from here. So this blue maybe represent the aqueous phase and the red one again the oily phase, and then we have the collision here in this area here, but the gas must transport this emulsion, what happens here, out of the machine. The pressure is up to 1,000 bar, and we have a high velocity of both streams, which have the collision here. But we have not a pre-emulsion, so we have a relationship to our technique. Nevertheless, we can distinguish it from our technology, and our technology will be carried out in such a machine. This machine is from an Italian company, Canon, and from Milano, German Mailand. And you see here, this is the collision chamber or the mixing chamber. We have two pumps. Yeah, they can produce up to 250 bars, not 1,000 or 1,500 bars. So the pressure is lower, that's all. And you see here behind, that's the second pitcher, 2 tanks for the aqueous and for the oily phase. They can thermostate it to a specific temperature. It must not be the same. That can be very important for producing cosmetical creams, because we have often there an oily phase what needs a special melting temperature. Yes, the capacity of this machine we have in our lab is 2 tons per hour. That is really an industrial scale, but it is not a disadvantage for working, because we have here a so-called control piston. Here is the mixing chamber, and the control piston can block the mixing chamber after producing a liter. This goes to an analytic, to the lab, runs out here, will be taken in bottles or something like this. And then when we put in the control piston, the oily phase will reduced, as well as the water, the aqueous phase. The steams are nozzled here. This is not demonstrated, not shown. The nozzles are the typical nozzles you know from the diesel engines, from the gas oil motors. However, this is a little bit activated here, and the piston will be retired, and then the mixing chamber is free, as you know, and then product will obtained and run out here. So we have a process maybe from 3 steps: nozzling, this injection, then the collusion with the impact and shearing, maybe a little bit mixing afterwards. So maybe we have a superimposition of several combination mechanisms. So then again blocked, and so we can say or let me repeat, we have an aqueous phase, an oily phase, we have this collusion directly, we have an emulsion, final emulsion, the product, we have no pre-emulsion, we have a fast process in milliseconds, we have a very narrow residence time. Distribution, please. I don't tell you that the rotor-stator systems need 20 minutes to produce a stable emulsions. So, and we have a very bright narrow resistance time there. Some little volume parts are going to the rotor-stator gap very often. Some never. Some of them never. So it's a very big disadvantage for this. But we have no additional gas addition, transport. So we have a distinction from the microjet reactors. So we have a lot of expertises in producing low viscosities. So from the beverage technology, it was a common project with my colleague, Professor Schneider, who is head of the beverage technology. So let me make it short. First of all, we make a so-called pre-emulsion. The pre-emulsion, for the pre-emulsion, we have maybe a percentage of oil of 10%. That is very small. Better would be higher. Best would be 50%. So both stream had the same range of mass, so as well of velocity as well as the so-called impulse, but it's not possible to take more than 10%. And this pre-emulsion, what will be produced by a lot of companies, will be taken to the filling companies who carbonize the lemonades and dilute it with a lot of water. The dilution rate is 1 to 1,000, so we took 999 parts of water to 1 part of this pre-emulsion you see here. The problem is the technology we use now is not so good. I heard it everywhere that we have still problems with the stability. And if you make so-called lemonades, this special lemonades, we have the so-called rimming of the oil sails, a ring formation at the neck here. Maybe you can better show it here, not here. I will not show this. No, I have not this what I want to show you. But at this place, at the surface here, you get this rimming, this ring formation. So the essential oil will sample here. So, and the other part of the volumes will be more and more free of essential oil. So that's it's get a so-called homogeneous view. However, this is a instability, and this must be avoided. Yeah, I don't want to give you now a lecture about the so-called Stokes velocity. Yeah, but indeed, the beverage technologies take so-called weighting agent to reduce the difference in the density between the aqueous phase and the oil. Yeah, if we have no difference between these densities, we have no velocity. The velocity of the negative sedimentation, because the oil is not so heavy as a aqueous phase. Yeah, we will have a upcreaming. Yeah, so due to this, we have this ring formation here. We cannot change the viscosity. That's not good for the mouth feeling of the lemonade. But we have big influence of the diameter of the droplets. So this should be in the field of 300 nanometers to 1,000 nanometers. That would be the best. This gives this heterogeneous view. This gives this cloudy view. What is important for this kind of lemonades? But this would be an advantage to have a small and narrow particle distribution, size distribution. So we measure this distribution with a different machines. Here the results. This is a laser friction measurement. Yes, and best would be such like this distribution. This narrow distribution would be the best. Normally, the conventional production, as I mentioned, is to take the high pressure homogenization and then later to dilute it and to carbonize it. And we make a lot of research here, and GGE is our technology. This is CFIT, but in a German abbreviation. And this is high pressure, the normal high pressure homogenizer. Yeah. So we have a lot of results here, but let me abbreviate this now. We were successful to make stable beverage emulsions in this milliseconds. Yeah. And we had a low temperature increase because in this short time we have less friction. So we have no heating up or less heating up by electric energy. So from the energy consumption view of point, we are better with this new technology. It's not the new technology, yeah, it came from the polyurethane industry, you know, but it's a nice tool. However, the pressure are not so high, yeah, and we were very successful in the range of 160 to 240 bars. We had also expertise producing cosmetical emulsions. We had other collaborators there from our cosmetical and pharmaceutical section. Here are some recipes, what's not so necessary in the moment. The recipes are very different, but the same principle. First heating up the both phases. The temperature may be different. Here not 70 degrees centigrade to 50 bars, and then making here the mixing in the chamber, and then filling, and then chilling, and then we have the ready to use emulsion. Let me show you examples. I have to shorten it up, I know. Here you see how the cream runs out of the machine. It's still fluid. We used only 40 bar. The temperature was 70 degrees centigrade, as well as the aqueous, that's the water phase. But after a short time, 10 minutes, we get this typical cream behavior, as you can see also in typical shop available creams. Yeah. So we have time enough, yeah, to fill, yeah, and whatever we want to do, because this, this stabilization comes a little bit later. This is the same, but the pressure is higher. The advantage is not so not better. So maybe 40 bars are enough. These particles here, these oily particles must not be so high as in the beverage emulsion technology. And here are some examples again between what temperature we took and what pressure we took, and we made a lot of analysis with rheological analysis. So we measured consistency factors and how big the particles are, the D90, something like this. Yeah, for here some other examples for our results, taking this pressures, and this gives us an idea about the distribution of size of the oily particles in these creams. However, very fast now. Yeah, and we made a lot of interesting rheological curves. Here's the so-called flow curves and the viscosity curves, and we measured the flow limit here, the flow limit, and yeah, we analyzed them very, very exactly. We make a lot of sensorical characterization. Excuse me, I have not translated it. So let me come back to this technology in general. We have a lot of experience with this technology, but not in the field of dairy. We can make a lot of nice cosmetical emulsions. My samples I have still in my office are still stable after, some of them still stable after 11 years. Yeah, no problem. Yeah, and sometimes I have a so-called synerases with a xanthane stabilization. What is possible with this machine? We have nothing. After 12 years, the creams are still okay. Yeah, we have a lot of experience. So also to add this xanthane and other things. We have also experience with water, oil emulsions, so-called fatty creams, and. Yeah, and let me come to the end. Let me mention the advantage. First of all, this counterflow injection technology allows to produce stable emulsion of very different viscosities in milliseconds. I would say this is very nice. This is surprising. We need no premix. It's not necessary. Never. Yeah. Yeah. We have this milliseconds. We have a narrow resistance time. We have easy CIP, clean in place. We have a low internal residue of products. That is important to producing these creams with rotor stator systems. Afterwards, yeah, it's mancraft to put all this rest of the material out of the machines. We can realize fast product change. Yeah, we have a low pressure in comparison to other Counterstream technologies. We have low process temperatures. We can make other temperature for the one and for the second phase. Yeah, we have low friction, so low heating up by friction. We have low electric heating. We have a well-tested and robust apparatus in an industrial scale. Nevertheless, small batches are possible. Please think for this piston. We can add additional substance, aroma substance, colorants as well. This is technology in the rubber industry to make it very, very sensitively. Yeah. So we have a lot of advantage of this technology, and I'm not, I don't understand why this technology is not more common in the consumer industry. And yeah, I make a little bit advertisement for it. Yeah, to clean it is no problem. Daniel, the next speaker, is also a specialist in making hygienic design. Maybe Daniel, you will present yourself. So it's no problem to clean the machine. Yeah. However, let me stop now. I'm over the time, I know. But what we can do in the field of dairy industry, maybe cream production, we can make a homogenization of milk, because in the dairy industry, we separate all the time fat first with the so-called cream phase from the skimmed milk phase. We separate them totally, and after that we combine it again. For example, in Germany, we prefer to drink lower fat milk, like 1.5% content of fat in the milk, but we must take less skimmed milk, but later we can add other milk, other skimmed milk. So we need, of course, a better relation between the both phases. The mass relation is important, not to take 1.4% and 98.5. That's not similar enough. But we can also use it for the ice cream production, I'm convinced, because there we add a cream phase directly. So we had a lot of chance to think about the transfer of CFIT to the dairy industry. And let me neglect the other slides in due to the time. So let me thank you for your attention, and special thanks to my co-workers and colleagues from inside, from outside, and thank you for your attention again. Bye, and now I'm ready to answer question if you want. Bye-bye.
Thank you, Uli. We got one question from Jahinda. Jahinda is asking, how easy would it be to add your CFIT technology into existing production lines, or would you need to redesign the entire processing line?
It's independent of the kind of industry, and so for the viscosity of the end product. So cream is a high viscosity end product, and a beverage is a low one, as well milk. So it's, I would say, easy to bring it in the cosmetical industry. You must only reset one machine, the rotor stator apparatus. But it's not so nice, because it's all relationship between machinery builders and using industry as well. So it's not so easy to come in this market. In the dairy industry, if I take the example of making milk, normal milk. You separate the fat from the skimmed milk. Everybody do it, and then you recombine as the desired fat content you will have later. So this is the technology to make a recombination, and afterwards you must dilute skim milk, because so otherwise you had not the low percentage of the fat in the consumer milk. So you have an additional machine, this dilution machine, however, but it's not a problem, I would say. I'm convinced the advantage are so high that I guess myself why this technology is not more common. I don't know. I would say with a positive thinking, it could be used everywhere. Okay.
Yeah. Okay. Thank you.
I cannot answer more concrete.
Yeah.
We have to ask the people first, make advertisement, and then ask the people, yes, why you don't use it or you don't want to use it. Yes.
Okay, thank you, Uli. Conscious of time, we move on to the next speaker, Daniel von der Gablens, who is the Managing Director of Ret Engineering Limited. Daniel will present on validation of dairy bottling plants, or give us an insight into why validation is needed, how validation works, very briefly. Just a little about Daniel. Daniel did an apprenticeship scheme at Völke Juice Company, did a bachelor's degree and a master's degree at THOWL, the very same university Uli is teaching. He became the managing director of Ret Engineering in 2016, and is also the managing director since 2017 of the German Institute of Rehygienization. Then his company is specialized to offer a patent-granted spray shadow test for equipment validation, particularly for the food and the fast-moving consumer goods sector. Further, the company delivers consultancy to a range of companies in the field relating to issues around hygiene, food safety, equipment design, equipment validation, of course, process optimization. And Daniel himself is also a visiting lecturer at THOWL, so a very busy man. And over to you, Daniel.
Thank you, Daniel, for the introduction. So I try to keep up, but I won't get the 1 o'clock PM, but I'm keeping up, so we are a bit quicker. So let me first give you a short overview of my company, IAgrE Engineering. So what do we do the most? The most we do is troubleshooting. If you're going to have microbiological issues, and I promise you, every company is going to have some, also no one wants to talk about, but you know, if you can't find the source, so we're going to watch for it and find it, and to do root cause analysis. And also what we do a lot is validations, especially of Azoptic and ultra clean filling lines. So, and that is my topic today, validation of Azoptic filling lines. To give you a short overview, we're going to take a look at when are Azoptic filling machines required for your production? What can you do with a product that you don't need an aseptic filling line and you can go with a conventional filling line perhaps? Why should you do a validation or even a revalidation of your aseptic filling lines? And then we're going to take a look at some important tests. These are not all tests which are recommended, but within the time I have, I'm going to introduce you to the most important tests in my opinion. So let's have a look. When are aseptic filling lines required? Most important is, of course, the pH. The higher the pH is, the higher are the hygiene requirements. You have the most sensitive products are products with a pH above 4.5, but even with products a little bit below 4.5, we also recommend to use aseptic filling lines. Then you have for sensitive products, ultra clean filling lines and products which are only have an enhanced shelf life, or you can even hot fill. You can use conventional filling lines. So why is the pH that important? To give you a short overview, here you can see pathogens, when do they grow? The convention is to say below a pH of 4.5, no pathogens, so dangerous microorganisms that are dangerous to the human and you can get thick of it. These pathogens can't grow below a pH of 4.5. I recommend to go for 4.3 or even 4.0 because if your product is cloudy, the pathogens are more protected, a little bit more. So that is, molds and yeasts are growing in nearly all pH levels, but yeasts, for example, and lactic acid bacteria can easily be killed by heat. So to give you an overview, what are norms, what we have here, I'm going to talk about aseptic lines with category 5. It is the UDMA nomenclature. You have aseptic filling lines, category 5. This is the high-end machine. Below that, you have ultra clean filling lines, category 4, and top hygienic, category 3. In the UK, you have got an own regulation, E or F. I'm going to stick to the UDMA recommendation. You can here see in Germany, we have the ISO norm. So they're going to say particles per cubic meter. In my opinion, it is not the right way to go for particles. You should go for microorganism because do you have a problem with a few particles in your product, even small particles? Or is the more problem the microorganism? In my opinion, it is the microorganism. Of course, if you have more particles, you have a higher risk for having microorganism, for carrying microorganism with it. But I recommend to check for microorganism. So what can you do that you don't need an aseptic filling line? And why should you try to not need an aseptic filling line? Aseptic filling line compared to conventional filling line, it is the high-end machine, so you need a lot of maintenance and you really need to stick to the recommendations for maintenance and do it before you have any problems. You need experts for this line and be really sensitive with these lines and do a lot of things. CIP, SIP will need a lot more time than in conventional filling lines. So that could be a reason to go for a conventional filling lines. If you're able to, you can drop, for example, the pH by changing the recipe with adding acid substances. Perhaps you can sell your product with a little bit lower pH if possible. Yeah, something to think of. If you are allowed to and the customer accepts it, you can use preservatives. It's always depending on the country where you are and how your customers are and if they are sensitive to these preservatives, but it's also an alternative. What you also can do, this is a solution for cans, because for cans, for the metallic cans, you don't have aseptic filling lines. They do not exist because there is a problem sterilizing the lid. You can sterilize the whole container using, for example, an autoclave. It's also an option. You're going to have a lot of more heat treatment, of course. It is negative for the taste of your product, of course it is, but it is an option to go for. So what should you check during the commission and why should you do a validation? You have to ensure the absolute hygiene function of your machine. You really have to be sure there is nothing. If you produce a batch or even more, several batches which are contaminated, you know, it is really, really expensive. And if you have a product with a pH above 4.5, it is really dangerous to people. So you need absolute hygiene function. And the validation is something to make it sure. Your random sampling you do typically on the lines doesn't draw the full pictures. You are a bit limited. So with these samples you can take regularly, you have 95% safety. So 95% if you're producing 30,000 units per hour, 95%, there are a lot of products you're not sure. So validation can identify systematic flaws and errors. Later on, I am going to show you a schedule how we do this, how we do a validation. So in this time, when there is a flaw or an error, we can see it. If you have a systematic flaw or error, we're going to see it. But on one-time event, we can't see on the validation. So it is also important to do your random sampling, not only the validation, because it also has its limits. What I can recommend is the UDI direction 4066. They give recommendations and requirements how to handle aseptic filling lines. Also, your line should meet the specifications of UDMA standard sheets. So now let's go to the tests. I have three main tests I want to talk about with you. At first, how to check the cleaning in place and sterilization in place. First, of course, you need to check the concentration of your cleaning and disinfectants agents. You also need to take a look at the flow velocity inside your pipes. It is a problem, of course, if it is too low, if it is really slow, you're going to need really, really long times. And you even can get problems if the velocity is too high. You're going to have shadows in your bows inside your piping. There might be problems. So we recommend to check the flow velocity. Then we're going to test the automatic interior cleaning program of your filling line. Azoptic filling lines always have got an internal cleaning system, automatic cleaning system inside the filler and seamer. You've got a lot of nozzles. If you have foam cleaning, or even if you have alkalinic cleaning, what is sprayed first? The window, and you won't see anything. So We have developed the RET test, the spray shadow test. We've got a patent on it. And I'm going to show you some pictures, how it looks like, and it is really easy to evaluate. You can evaluate if you have reached all parts with the RET test. Then also really important is for the sterilization pace, the SIP, to evaluate if you have reached the critical temperature at all parts. So we use for it thermostripes or thermostickers. You usually stick them on. We recommend not to stick them on the pipes, stick them on the flank, because you want to make sure the whole flank is getting hot. So now let's have a look at the RET medium. This is our red RET medium. You spray it on. It is no nutrition for microorganism inside, so that's a big benefit. You easily spray it on, dry it for 15 minutes. Then you make your CIP, and after that you check it, and you easily visually can see if there is rest of RET medium and even bleeding out of seals. We used here swab, microbiological swab. It is dry, white, and also for pictures it's good. You can see it really good on the picture if you're bleeding out of this, so there is rest inside. Then we do challenge test. We produce 50 to 100,000 containers. It is depending on your contract, what is guaranteed. These containers are production fully filled with a sensitive product, stored for 28 by 28 degrees Celsius. I'm sorry for going with degrees Celsius, but yeah, for 21 days. And after that, we usually check if there is any microorganism contamination. If you have one, you will get spoilage or it will be cloudy. So an easy step. So then we do microbiological step control with product and supply medium. For example, we take the whole first filling cycle, all 5,000 containers, we take 4 for investigation in the lab, last filling cycle. Then we stop the equipment, and there is product from inside your sterile buffer tank to the flow. You usually stop it and let the line stand still till end of the sterile time, mostly 72 hours. You do a microbiological step control every 24 hours. And after the end of the sterile period, we're going to fill about 10,000 containers, 50% filled, which are also stored 28 degrees Celsius for 21 days. Why going with 50%? You have a bit more air and the microorganism can develop better. So we have a stress test for these line with these tests. After finished the 10,000 containers, we're going to take air samples. We want to test if there is any microorganism. We recommend to take 1 cubic meter. And we do microbiological swabbing. So we're going to use 3 to 4 media. It is product specific, so we have to take a look which product are using. We always do aerobic and anaerobic swabs. So mostly your product is anaerobic inside the container. Rule of thumb, we take 60 spots with 3 to 4 spots each, but it is depending on your specific equipment. To give you a number, it is not the routine control. Routine control, you will do 15 to 20 swaps. We do about 60, sometimes 70 swaps. So it will take a bit of time, of course. Then we're going to do a count reduction test. You want to make sure that the disinfection of your lids and containers works correct. So the UDMA and UDI 4066 has recommendations for it. For staining of a specific microorganism, these are spores of the microorganism. And you have for disinfectants, Bacillus atropheus, sorry for pronouncing it in Germany. They are specified here. For recirculating system, for round filling lines, you take 20 lids and 20 containers for sampling. And you always take 5 containers not treated, but for also you get it to the line to check that nothing happened within the transport. For linear systems, you take 5 lids and containers per row. So if you have 7 or 8 rows, these are a lot of more samples. Target for log reduction for Azoptic fitting lines, UDMA class 5 is log 5, count reduction for lid and container. UDMA class 4, you have log 4, so an ultra crane filling line. Very easy to mention. What do we always check? We check your routine testing. Is it correct or can it be enhanced? We're going to validate your flash pasteurizer or UHT system functionality. Typically it has a ramp. If you store buffer tank is full, it's going down and then keeping up the speed. So we check if everything is okay and calculate the pasteurization unit or even sterilization unit. Recalculated, we found faults in the past, so we check it always. We also check the documentation, the system internal documentation, and also the documentation your employees at line are going to do. What also is important is the training programs. Typically, if you buy a new line, you buy a training program from the company. So make sure there is a training program. When we do the validation, your employees are going to run the line, so we can check if everything is running fine or if there need to be anything enhanced. If you need a guideline for training, you can also go to the UDI direction 4066. They've got 5 letters out now, and one is for training your employees which are working at the line. So these are the most important tests I wanted to introduce you to give you an overview. Now I've got an exemplary schedule. It's only an exemplary to give you an overview, how much time we need, what is your shutdown time, the time you can't run your line normally. So we typically need Thursday evening, here is CIP, SIP, that's where we start with the validation and the line is shut down. I'm not going over all points here, only to give you an overview, and afterwards you can take a look inside, I think. So we're starting Thursday evening with the CIP, SIP, Friday production of the 100,000 cans, Saturday and Sunday only step control, Monday we're going to fill the 10,000 cans, do the other test, count reduction test, the spray shadow test, and so on. And then after that, CIP, SIP, and the line is back yours. So we are finished with the test on Tuesday. We then collect rest of data, thermostripes, and so on. So there the line can run automatically in normal production. So the most important thing you should remember of these short presentation, I don't think I'm sure, so is UDMA professional letters, UDI direction 4066, really helpful. If you need an RET spray shadow test, Ret Medium, contact us, the German Institute of Rehomogenization. If you need support with the validation, contact IAgrE Engineering. And that's it from my side. Try to keep up, so I'm with 21 minutes, so should be fine. Thank you very much. Do you have any questions? So the time, so I've seen here one question from Yendra. Sorry for not correctly pronouncing your name. So how long does it usually take to validate the line? You can see in the schedule, we're starting on Thursday evening with the validation, and the line is back yours. You can run normal production on end of Monday. So 18 o'clock and 6 o'clock p.m. The line is back yours. The 95% safety is improved to your second question. How does the validation improve the 95% safety from a random testing? You have here a 100% control over these 110,000 containers because of storing them 28 degrees, 21 days. And with the additional checks we do over the whole sterile time, if there is any contamination coming inside, to give it time and simulate with the stop really hard time for the line. It is a lot harder for the line to stand still, not moving after 100,000 till the end of the sterile time. We can make sure the line works 100% for this step. So if you have a systematically failure, we will find it with 100%. If it is a random one, not systematically, a one-time failure, if it doesn't happen within these 72 hours, we are not able to find it. Then you have to trust your 95% of random testing. So it has also, validation has its limits, but it is the best you can do. And I can tell you from my experience in troubleshooting, most companies I go to for troubleshooting haven't done validation for several years. I recommend, and the recommendation UDI 4066 letter 5 gives is to revalidate your line, for example, yearly after the yearly overhaul. I recommend to wait 1 or 2 weeks after the overhaul, because directly after the overhauls, in our experience, you're going to have some issues, failures, pump not placed correctly, a small leak or anything that could influence the validation, of course, and we have to abort it. So I recommend to wait 1 or 2 weeks and then do a revalidation. Any other questions?
I think that's it. Thank you, everyone. Well, thank you for attending our dairy week. I hand over to Charlie to just have a few words to wrap up things.
Thank you, Daniel. Yeah, I mean, we have gone over a little bit, but never mind. I'll keep this really brief because we have.
I can't hear you.
Oh, can you not hear me?
I can hear you.
Oh, okay. Can you hear okay? Yeah. Yeah, I will keep it brief. I just want to say thank you to all our presenters this week for giving an excellent insight into what is a very sophisticated industry. It's certainly a far cry from what the average person's perception is of how we get milk onto the shelves in the shops. We've seen presentations on the whole process from cutting edge dairy farming and the equipment and technology that's used and how it's developed, through to complex processing and monitoring of quality. And we've seen a variety of different uses of both cow and goat's milk, which is viewed as a highly valued, good source of nutrition for people. I hope the event's been useful to people. We've had a real international attendance this week, which is great to see. Thanks for everybody for that. All the sessions are recorded so they can go onto our website. So even though people have had to dive off the call, they can go back and look at the presentations. If anybody is interested in joining the Institute of Agricultural Engineers, then please see our website for details, IAgrE.org. You can see the letters behind mine and Daniel's backdrops. Last but not least, I'd like to thank Daniel and Sarah for putting the event together this week. And please do look out for future events from IAgrE. So thanks again for joining. Bye-bye.